So, we're broadcasting live. Welcome to this webinar, the first day of a two-day series of webinars with the subject Voyage Efficiency for CII Compliance. On today, it's arranged by BS Group, and it's sponsored by sponsors today is VesOPS, Navtor, OneOcean, and Vessel Performance Solutions. And today you will hear presentations from VesOPS, OneOcean, Navtor, Solvang ASA, and Vessel Performance Solutions. So the idea is that each presenter will present their topic, and you can ask questions in the Q&A section. We'll try to answer as many questions as we can from the Q&A. So once all presentations are done, we will have a discussion, questions answered section that will last around half an hour. I will start by presenting, so I'll just shift to my screen. Just a second. So I'm presenting from the company VesOPS, and the topic is there a link between the CII and the fuel efficiency? It's presented by me, Soren Vinther Hansen. I'm first of all a master mariner, sailed for many years. Then I'm a naval architect and a PhD from the Technical University in Denmark. I have an extensive experience within the field of performance optimization of ships. I've been working in shipping companies for Class Society and various service providers. And now I'm director in the company VesOPS. And VesOPS is something I founded a year ago or something like that in 2020, late 2020. We are delivering vessel performance monitoring software, and we're doing analysis for ship owners. We deliver expert advice on operational and environmental performance for the international shipping industry. And we are based in Denmark with a worldwide distributed client base. We are going to talk about the CII today, and I guess we'll see a lot of explanations to various views on the CII. I'll just be quite quick on that one. So IMO chose the CII to be the annual efficiency ratio. So every vessel has to submit IMO DCS data, and from the IMO DCS data, AER is calculated. That's the fuel oil consumption, the CO2 emission factor, the annual distance sailed, and then the capacity of the vessel. That gives the AER. This regulation will enter into force 1st of January 2023, and IMO has implemented this in a strategy to reduce the GHG emissions from shipping. Vessels are rated, so there's an average rating for each vessel type. That's a C rating, and then if you are better than the C rating, then you can be rated A or B, or if you sail worse than a C rating, then you can be rated D and E. The ratings are strengthened every year, so in 2023 it'll be it's all related to the 2019 numbers for the IMO DCS. So in 2023 it'll be 5% more strict on the C rating, and in 2026 it'll be 11% more strict on the C rating. And what happens after 2026 we don't know yet, but it's to be decided in IMO, and then for the remaining period up to 2030 there'll be some other regulations. It also implies the SEMP, so there will be a part 3 in the SEMP, and you have to give a target for coming CII for the next year and the next 3 years, you'll have to give a target for the CII. You'll have to describe how you monitor it. And if you're rated D or E, which can be serious for you if you're a vessel owner, because you can be in rating D for 3 consecutive years, but you can only be in rating E for a consecutive 1 year, and you have to submit a plan to how to get out of rating E. And it's all verified by Klaus, and they'll come and verify it once a year. So I've set up a few case studies just to show you what is the CII dependent on. So if we take a fleet of bulk carriers like these, there's different sizes here, and this is from 2019, the CII rating for these bulk carriers. If we look specifically at the Kamsarmax class, then I picked out 3 vessels, one with a rating A and two others with rating E's. They sail different distances. They emit different amounts of CO2, and you can see there's from the best vessel, which emits around 17,000 tons, to the next vessel, it emits a little more than 18,000 tons, but still it's rated E compared to the A. So it's not only CO2 emissions that decides the rating. There's other factors involved in this also. So if we take case 2 and 3, which were the E-rated vessels, you can see if you go out on in the table on the right, you'll see the CO2 emissions for the year. It's 18,000 for vessel 2, and it's 23,000, almost 24,000 for vessel 3. So there's a big difference in the CO2 emissions for the 2 vessels, but they are rated the same, and the CII is almost the same. Then we can go down and look at the sail distance, and you can see there's a difference between the sail distance on vessel 2 and vessel 3, where vessel 3 has the longest sail distance. The number of voyage legs are also different. So the vessel 2 has more voyage legs than vessel 3 has, and the speed is a little bit higher when it's sailing at sea than vessel 3. So the CO2 emissions combined with the sail distance, combined with the number of voyage legs or the idle period, also has an impact on the CII. So that's something that you need to consider when you are planning for your vessels for a future operation. If we look at the two, the one with the rating A and the one with the rating E, you can see there's a difference in the CO2 emissions, of course, for the 2 vessels. But you can also see there's a large difference in the sail distance and the number of voyage legs, but the speed and the draft are almost the same. And that gives a very good rating for vessel E because it's more energy efficient. It's a newer vessel. It's built up to the EEDI scheme when it came into force. And then it sailed a longer distance, and it had less voyage legs than the bad rating vessels, the bad rated vessel. So you can speculate a little bit on your routes with your when you want to plan for your vessels, because there are CII good routes and CII not so good routes. So the blue route is bad for your CII, even though this vessel on the blue route has sailed with a lot of cargo. It's been full almost all the time while it sailed. It sailed short distances. It's had a long idle periods, where the orange vessel has sailed a lot of miles. It sailed a lot in ballast, and that is beneficial for the CII. So that's something that maybe is not intended for the CII and the CO2 emissions, but this is how it works with the CII that's decided right now. You can also maintain your vessels, maintain the hull and maintain the propeller to keep it in good shape all the time. So here's an example of 7 vessels from a fleet, where from 2019 to 2020, there's been an improvement in the CII for almost all vessels. And the ones who went from rating C to rating A is because they were dry docked and they were painted, and they were sent out with fresh paint on their new voyages. So you can also see on the CII if you do something for your maintenance of your vessels, and if you take care of the performance. And then finally, there's something also we need to be discussed, is that there's an owner and there's a charterer. So let's say that I'm an owner, I have a vessel, I want to charter it out for a charter. He wants to sail from Argentina to China with goods, so I charter it out for a year. I can relax, my fuel is paid, the expenses are paid for my crew, and I don't really have to take care anymore. The charter, he might be busy, he wants to sail full speed ahead with this vessel to utilize it to the max. And then I started the year by thinking when I end the year, I would be in rating C. But then after the year where the charter, he really sailed very hard with my vessel, then I come out with a rated E vessel. And then the charter delivers the vessel back, and then I have a rated E vessel that I need to charter out one more time. And I would have problems here with getting a new charter for my vessel, because there will be restrictions on my vessel's operations. Because I'm rated E, I have to submit a plan how to get out of the rating E, and that would probably put some limitation on my operations. So there will be some discussions between the charter and the owner, and some agreement on how should this come out when the charter agreement is done. So a recap on this: the CII is a KPI for the energy efficiency and the CO2 emissions from the ships, but it's dependent on the operational profile, so the sail distance, the idle time, the utilization of the ship, and the CII beneficial sailing route. So it's not only energy efficiency that we are looking at; we are also looking at the operational profile. It's also dependent on the energy efficiency, so careful maintenance of the hull and the propeller and the engine, and then continuous vessel performance monitoring to track of this while the ship is in operations. That, of course, leads you to where I am, because I'm delivering software that provides you insight if you are a ship owner on how is it going for your vessels. So by choosing software products like the one I represent, then you would be able to digitize your operations, you would be able to organize your data, and then you will be able to monitor the vessel's progress. And then by sharing this information to the stakeholders in the operations of the vessels, that would create awareness among all stakeholders. And that could be a sharing platform for both charterers and also for the owners. And then, of course, you need to set targets for future operations. And I think we'll meet some of the providers that are presenting in this sessions here, that they have some solutions for that also. So to be competitive and to distinct your vessel in the market, it will be imperative to keep control of your CII ratings. And the CII rating is something everybody understands. It's a very simple number. It's something that a lot of people will take decisions on, even though you could discuss if you can take a lot of decisions on it. But I think that is what we will see in the future. So that was my short introduction to this. And if you have any questions for this presentation, please go ahead and submit them in the Q&A. And now we'll go with the next presenter. This is Jeremy Daoust. Am I pronouncing it right, Jeremy?
You did. Thank you.
From OneOcean. Can you tell us a little bit about yourself, Jeremy, and then go on to your presentation?
Yeah, perfect. Thank you very much. Good day, all. My name is Jeremy. I'm Director of Product Planning here with OneOcean. I've been with OneOcean for about a year, responsible for the wonderful product development and roadmap of our solutions to meet your requirements, customer requirements. Previously was a fleet manager at a company called FedNav. here in Montreal, managing 65 vessels. So I really understand the topic, our topic, which is operational impact. And I really look forward to sharing this concept or these moments with you. So I'll share my screen. Okay, so decarbonizing shipping, the operational impact. I think this actually segues really well with where the previous speaker started. One of the quick things is and you're quite right, CII is simple to understand, and it's not going anywhere. It's not going to leave. It's going to stay in the industry. Decarbonization is as you can see by the roadmap that we have, or the timeline that we have in front here. We have a lot of aggressive milestones coming our way, and I think it's going to be really interesting how we get there. And so we need to be smart about it, and we need to start thinking now. One of the things that is always clear to me as a human being, I guess, or somebody in shipping, is our love of timelines. I think we really, as an industry, love timelines, and we love to present elements on a timeline. Now, this is the greenhouse gas. This is the essentially decarbonization timeline. And one of the first takeaways that we need to think about is this is misleading, and decarbonization is not happening in a silo, right? These regulations and these requirements are happening on top of things that are already put in place that we as an industry and our seafarers and our ships need to adhere to, right? And so not in a silo and on top of things that are happening. If you look at the top of this particular timeline, you will see these are regulations. Now, these aren't regulations that happen a year and then disappear. These regulations compound on top of one and the other, and they compound on other regulations that are already coming in place or have already been brought in place. So how do we, as an industry, need to digest this? Well, the reality is, the feeling of, and I'm going to use the word feeling because it is a feeling, it's not a reality, but the feeling is that these regulatory requirements are overloading now the ship, in this case, as a metaphor, but there's a feeling of being overloaded by the complexity, the quantity of regulatory requirements. Now, the neat bit about regulatory requirements is they're extremely important, but they don't happen unless you're operating, right? They don't happen really unless you have a voyage, unless you're sailing. And the operational realities of sailing are extremely complicated just in and of themselves, right? We have, as seafarers and as ship and shore teams, we have a plethora of work that we need to do just to be able to trade, right? We've got our class annuals, we have MLC, ISM audits, we've got logbooks that we need to maintain, PNC inspection, maintenance reports, vetting audits, pilotage, SMS, bunker reports, HSEQ reports, PMSs, pre-arrival management, bunkering, noon reports, passage planning, port clearance, and so on and so forth. Extremely complex and takes quite a lot of time just even to maintain a ship while en route. On top of that, we have new items that are coming into play, into force every day. Global pandemics, crew pressures. We talk about commercial schisms, commercial versus operational schisms between the charterer and the operator, charterer, owner, and so on. These are going to get accentuated. Green supply chain pressures, and of course, geopolitical pressures. And I need not go into those details with what's happening around the world. Now, these operational realities are complex, right? There are more dimensions to worry about than ever before. The increased complexity, they're essentially increasing the complexity of regulatory compliance. And as stakeholders, we still need to operate through all of this, right? This is a very important kind of status to be in and to understand. Now, I think the best way to understand operational impact is to talk about an operation. So let's roll with a use case, right? It's August 2023. I've got a 2008 35-ton Laker. Okay, the master's been given loose voyage instructions to head to the Baltic, to the Black Sea rather, to load steel plates with a disport in Detroit, right? Very common route, bringing steel plates to Detroit. Now, one of the things that is interesting about this is the superintendents and the owner have done a good job of understanding EEXI. And unfortunately, the rating for this particular ship, because of historical IMO DCS, have given her a rating of D. So they've got a lot of work to do to bring her to a B to an A. As such, they've developed a good SEMP, or they've developed a SEMP rather, or enhanced SEMP, and they've put in place EEXI, and their chosen path for the time being is EPL, engine performance limitation, and they've derated the ship. All right, cool. So the master and the ship don't know this, but we know this, that the next voyage, and this is just for kind of for fun and for you all to enjoy it and see where this is going, but the next part, the next voyage after this one looks like it's going to be a voyage of grain out of Thunder Bay to Morocco. Okay, so keep that in your mind. You'll see in a way of decision making how this impacts. So now the master receives his full instructions. He's typically going into Mariupol, to be honest, historically for this type of cargo. That's where he would go. And now, as a result of what we know is happening, or what has happened in this case, because it's 2023, let's assume that the supply chain has shifted. And actually, the load port is Constanța in Romania. He's never been there. So he receives instructions to go there. He's never been there. Nobody on the ship has been there. He's a bit stressed. It's not a big deal. Usually masters and ship officers are this is commonplace for them. Suffice it to say, though, they usually go to a place and this brings something new. So they're a bit worried. They're a bit concerned. There's a bit of anxiety aboard the vessel. And so they immediately contact the port agent and they try to get information regarding the port. And they scour their documentation and the internet to figure out information about the port. Perfect. They arrive, they start to load, and they head out. Immediately, as they're starting to complete the loadings, the navigation officer, of course, is busy putting together a passage plan that satisfies the nature of what he understands is to be the contract, as well as the forecasted weather and the different parameters, and he believes he's created a solid passage plan. In this use case, he's still using an Excel spreadsheet and Word document. Maybe he's using a form of, digital routing, but nothing too sophisticated. The vessel's not there yet in terms of its digital maturity. Heading out of Jib, however, things change. Oh no, weather patterns have started to shift, and there's a major storm that's actually progressing a lot faster out of the North Atlantic. It's going to transect the current passage. Now, the master right away kind of flags the navigation officer and then asks him to create multiple weather routing scenarios to mitigate or avoid this particular storm system. The issue is this vessel is not operating like it used to. This vessel has had EEXI in methodology, engine performance limitations. So this derating of the main engine, same engine that was, say historically, this was a 7,000 kilowatt engine. Now she's a 6,000 or 6,500 kilowatt engine because of the derate. The master is a bit concerned about this because he's never been through this kind of storm, even the tail end, even the side of a storm like this with such limited power. And so he errs on the side of caution and asks his navigation officer to give him a little bit more extra leg room to avoid the storm because of the risk to the crew, the ship, and the cargo. As such, the master sends a note to the superintendent advising of what he's doing, continues with the passage plan. So he's still sailing in this right. That vessel's still sailing, derating. It's deviated a little bit, but now the navigation officer is able to finish the passage plan utilizing his tools, and the master submits a amended passage plan with a major deviation. Right, deviation looks like 5 additional days. Yeah, it feels like a lot. But the master is worried because, again, he's never been in this situation with this particular ship with this lack of power. So the master submits this to the superintendent and to the operator. Well, guess what? The operator responds vehemently right after with a, "Are you kidding me? The charter is going to be extremely upset. Our laycan is extremely tight. You need to go faster. You need to make up time." Master says, "I can't make up time. I've got EEXI enabled. I've got my ship has been derated. This is what we can do. This is as best as we can do, sir." And the master continues along his voyage. Now the charter is upset. The charterer will impose penalties as a result of the contract. But what we can do, it is what it is. The operator is upset. We move on. So now the master is stressed. Everybody's stressed aboard because of this particular condition. Now we've, number one, understand everybody that we've done a major deviation as a result of the storm, but also as a result of the engine performance limiting. What is that going to do to the CII? That's the first thing that we need to think about, right? Additional mileage, even if it's or additional nautical miles, unplanned nautical miles. So this will have an impact to the particular CII endeavors of the voyage, or thought process tied to this particular voyage. Now, we're still operating, right? We're still heading into the Great Lakes. Prior to going to the Great Lakes, everybody knows this, or most of you hopefully have sailed or understand that it is complicated. You've got a lot of pilotage. You've got to make way, be ready for the seaway. As a result, you got to do saltwater exchange or saltwater flushing for your no bob or ballasting condition. You have pilots. You have seaway inspections. You've got 8 locks essentially before you get into the Detroit area. You've got pre-arrival, port of arrival, port clearance. Chances are you're going to get a USCG PSC, or at least inspection or hello. So you got to make ready for that. All of these things to make ready. Now the master and the vessel's about to arrive at the berth. There's a bit of current. I'm a bit stressed. I would typically call for two tugs, but I know the operator's upset, and I know he's only booked maybe 1 tug for this particular voyage. So I'm going to do it with 1. And guess what? We succeed. Great. We're happy, but we're stressed. All right. Now we've done with the pleasantries. We've trained the stevedores on how to use the cranes, signed off, cargo loading, cargo discharging commences. Oh man. Red alert in the ship's office. The ballast water treatment system is clogging. Cargo operations have slowed down because, of course, if your intake of ballast is reduced, your cargo discharge is reduced, right? Because of stability calculations and concerns. Chief mate reaches the master and the chief engineer and says, look, the muddy water here is so crap that, unfortunately, the candle filter is clogging. Candle filter is clogging. I'm not able to. So as a result, the system's trying to derate as best as possible to continue taking on compliant ballast. Well, the master, does he call the operator? This is going to cost, if we are at a third the discharge rate, it's going to cost us a lot of money. It's going to, oh my God, no. Okay, bypass the ballast water management, the ballast water treatment system. And look, I think we're going to be okay. Let's just bypass it, take on ballast, continue discharging, and we'll make our way out. Perfect. Everything happens like that. Discharge is complete. Master starts to make ready to sail out and receives his instructions. Oh, you're going to Thunder Bay to load grain and then to Morocco. Uh-oh. I've got non-compliant ballast aboard the vessel. I've not told anybody. What do I do? Well, I got to come clean. So I come clean. Unfortunately, because of congestion in the anchorage and congestion at berths, there's no way for me to do any kind of maneuvers or deballast and ballasting in the air. In fact, from a regulations perspective, I have to go 12 nautical miles outside of the EEZ to redo the ballasting operations to be able to go to Canada, which is essentially in the same body of water, but it's on the other side. So I got to go to Canada in order for me to go to Thunder Bay. What does that do to my CII? What does that do to my commercial contract? Now, I've got no other vessels. The operators told me there are no other vessels that have been nominated. You're the only vessel in the area. And so nobody's happy. All right, so we've got impacts, we've got EEXI, we've got routing, CII, we've got commercial, geopolitical, operational, and ballasting issues, all in this lovely use case. In way of an impact, so what is the operational impact, if you will, of CII, which was our decarbonization, which was essentially the decision-making of having a static rather than dynamic EEXI strategy? Well, we've got delays. Delays led to missed LACAN and subsequent CP penalties. We've got additional fuel spent and subsequent impact on P&L, right? We've got compliance impact because we've got negative impact on our CII, and we've actually, due to commercial pressures, taking on non-compliant ballast and had to deal with that. We've got environmental impacts because at the end of the day, guess what? We did produce more greenhouse gases. So we're actually going against what we should be doing. We've got crew workload. So the crew workload has increased. It's been suboptimal. And we've got risks galore, right? Major non-compliant risks, fatigue-induced errors, and customer loses confidence. Wow. Whew. Now that's heavy. And that's a reality. That can happen if you decide as an operator, as a system to just, bring in CII and decarbonization strategies without having to think. Now, all of us agree that that's an edge case and it's complex, but these happen on a daily basis, and there are tons of other edge cases that are similar to that and cases like that. My point is we have solutions. We just need to think about this. We need to have it think a little bit differently as stakeholders in shipping. And we need to look at this as a multi-dimensional, multi-stakeholder equation. Yeah, it's complex, but we need to understand that it's complex and treat it as such, respect it, and we can operate with that in mind. So decarbonization is not something that can be answered with a single linear direction, right? You need to think about it from a QHS perspective, navigation perspective, environmental perspective, or operational perspective and commercial. You also need to understand that you've got a lot of stakeholders in this equation, and each of these have their own KPIs and their own values, right? So you need to understand these two dynamics. You have levers for decarbonization, brilliant, and that's really, really important. And these levers come at you at different times, right? Different costs and different times. So strategically, you've got a lot to play here. So design and machinery is something typically that is high cost, long-term, more long-term, fuel as well, right? Depending on your operating model, fuel may not be an option, fuel changeovers or different fuels may not be a solution for you. But typically what's available for everybody is operational excellence and digital solutions. Usually that's relatively low OPEX and it can have immediate impact, right? So as an industry, how do we take all of this and how should we approach it? And we should approach it in like 3 phases, if you will. One, we need to understand strategically what this is. So we require multi-dimensional decision-making. We do require to be flexible and agile, right? Which means our processes or procedures need to be agile, flexible, right? I can't just say, I will have one EEXI strategy and then that's it. You need to understand that depending on the nature of the voyage and the events of a voyage, I need to be able to pivot and shift for a positive result for everybody. I need to collaborate and I need to understand the context. Now, we've got building blocks, processes, capabilities, and resources. We have amazing seafarers and shoreside superintendents and teams that are fantastic. We need to leverage them, right? We need to, and hopefully you'll get this, is operationalize our compliance and not just have it as a checkbox exercise, because we're going to fail if it becomes a checkbox exercise. We need to understand that we have who are the key stakeholders and empower them and make sure they can participate actively in the voyage and have a dynamic and common platform to communicate, right? A single source of truth. Phase 3 is really today, tactical. What should we be thinking about? Well, we've got some really fantastic processes. Let's reuse what's there. Let's use technology as an enabler and let's train our people. All right, what does this mean working with OneOcean? Well, let's look at the use case here. So if this particular vessel and ship manager was working with OneOcean, well, right away the enhanced SEMP could be built and operationalized within our DocMap product, which is a document management SMS solution that utilizes workflows and events to generate triggers. So this could operationalize a multidimensional EEXI strategy, for example. Within our OneOcean platform itself, we have an ability to create multiple routing profiles with all of these multiple EEXI strategies. And a well-versed navigation officer can create different EEXI routing strategies for optimal results basis the different events. And this they can do once these profiles have been created. It's pretty quick to do. Right, I'm concerned about a port. I don't know, a new port. I mean, anything that we can do as a company at OneOcean, we want to alleviate a lot of the burden of stress and anxiety because that leads to poor decision making. So oftentimes, the simple nature of not knowing or understanding what a port is and what are the boundaries of a port can lead to just stress and suboptimal processes. Well, guess what? Through our products now, our customers have access to a wealth of information and regulatory information regarding ports around the world. Routing could be, we can speed up in this particular use case. We could have sped up the routing and the planning and the replanning of passage plans to mitigate errors and mitigate commercial pressures, right, through our voyage management solution. Now, from a communication, collaboration, and stakeholder engagement, we have a software solution called Fleet Manager that could facilitate the shoreside equation, bringing all of these shoreside competency to the voyage by pushing a passage plan, by taking a look at what's happening. Both owners, operators can gain access to this particular solution and engage with the voyage. This is a very unique piece of software that we are going to be launching this year, and it is an environmental active timeline as part of our OneOcean Environment Manager Plus product offering. And this essentially will shoulder a lot of the burden of environmental compliance along any voyage. So in this particular case, the navigation officer, the captain, the environmental officer, there's such, and the chief engineer would have an ability to look at all upcoming environmental boundaries and regulations that the vessel would need to adhere to 12 hours ahead and plan for them on a single source of truth. And so this is, again, unique, and it's extremely powerful tool, and it could be changed and updated quickly for dynamic planning. Now, ballast operations is key, and we've just implemented ballast water management not too long ago. It's complex. And so with our dock map solution, again, you can create and build your ballast water management contingency plan, where you can develop different scenarios in the event that you know there's going to be an issue. You can also manage your ballast record book through a digital solution, which is Log Central, so that you've got full auditing and understanding what's happening from a ballasting perspective as a ship and shore stakeholder. And we are working actually in collaboration with OptiMarine to know about port water conditions before you get there. So creating a form of heat map of port water conditions and adding that to our solution, right? So if you were to take a look at this example, and if you had our OneOcean products aboard, delays still would exist, but they would be reduced. Commercial impacts heavily mitigated through real-time collaboration. Negative impact to CII mitigated, remove ballasting, non-compliance, essential reduce of GHG, and so on and so forth. All in all, the message is we're here to help. And I think this is complex, and I think we could do a lot together. So please reach out.
Thank you very much, Jeremy, for a very good and detailed presentation. If you could please check the Q&A for any questions, and we'll come back to you when we have the Q&A section at the end of the webinar. We'll go further to the next presenter. That's Aaron Holton from Navtor. Aaron, are you there?
Yep. Hi, Soren.
Hi. So Aaron, please say a few words about yourself and then go on with your presentation.
Yep, sure. Hi, everyone. My name is Aaron Holton. I'm a Vice President of Performance at Navtor. In my role, I support a range of kind of strategic digitalization initiatives for the company through our e-navigation and particularly our performance portfolio. Previously, I was the CEO of Tri Solutions, which was acquired by Navtor in 2021. And then feels like a lifetime ago, spent the earlier part of my career as a management consultant with Charles River Associates and PacWest Consulting, which was acquired by IHS Markit in 2014. And in that role, kind of focused on a number of kind of strategy projects and big data, advanced analytics, operations and implementation type work, as well as organizational development. So that's a little bit about me, and then let me jump into my presentation. So I think let me know when you can see my screen. I think you can now. So I think Soren did a good job of talking about the CII regulation overview, the calculation and baseline methodology. So he saved me a little time there, so I won't really recap that, but then kind of go through discussing and kind of elaborating on some of the key levers for improving the vessel level CII rating, as well as some of the solutions that we at Navtor have for monitoring and predicting the CII. So like I said, I'll skip these. I think Soren did a great job of recapping that, as well as the calculation methodology in place. So pass through. So essentially, once we go, again, the goal is to, as we mentioned here, to achieve a C rating or better. So I think Soren and both Jeremy touched on this, but we at Navtor look at kind of, especially from the performance side, look at a number of different levers and how we support our customers for improving that CII rating. So if we look at the attained CII calculation, which we know is kind of emissions per design deadweight ton or gross tonnage, depending on the vessel segment. And then distance. There are some certain things in there. We always talk about controlling the controllables. And so this emissions calculation is really annual consumption and an emissions factor. So what can we control within there? And some of these were already touched upon, but really we look at these in terms of operational and commercial levers, some machinery, equipment, or technical levers, maybe that we are less focused on, but companies can certainly pull those levers. And then kind of the fuel side. So how do you impact that emissions factor? And so I'll walk through some very simple case studies in terms of maybe speed reduction or base load reduction. So speed obviously can have a huge impact on consumption, looking at auxiliary consumption, both at sea and import. So import, where there's the ability to use shore power, you have the ability to influence your AER, which again is really your attained CII calculation. Also, kind of main engine performance optimization initiatives, hull cleanings, and routing optimization and guidance. And then on the machinery side, there's potential for installation of energy saving devices, hull form optimization. Even the choice of your paints and coatings can positively impact your rating. And then on the fuel side, there are a number of options, and I guess we kind of all know and can agree on the technical feasibility and commercialization of some of these, and kind of they're at different stages of the timing and feasibility spectrum. But I guess LNG would be more of the kind of proven fuel, and then also looking at kind of biofuels or drop-in fuels, which have positive potential, and then maybe looking kind of more longer term at things like ammonia and hydrogen for the vessels. And so these are things that you can do to impact, again, the emissions coming from the vessel, and then looking kind of at the distance part of the equation, kind of more commercial driven or market driven decisions around vessel utilization. So the simple way of thinking about this is the more time you spend at sea, obviously thinking kind of combining that with other factors around speed, you can positively impact your CII. A lot of time spent at idling can certainly adversely impact that, where you're emitting CO2, but you're not covering any distance. So we see a lot of our tanker and bulker customers that spend quite a bit of time, 50% of their time in idling. And so, of course, that has a negative impact on the CII rating. So kind of the segue into that is, again, keep in mind, this is a very simplistic case study here. And so there are a lot of factors that go into play in these calculations. But if we take kind of an MR tanker that's around 50,000 deadweight tons from our universe, that maybe at an average speed of 12.5 knots, that spends 50% of the time at sea and 50% time at idling, we can run a scenario on distance covered over a calendar year, as well as the CO2 emissions and the resultant CII score, AER score for that vessel. And so we'll look at a couple of those levers and the potential impact on the CII rating, starting with speed. So in the first scenario, we look at a 10% speed reduction, where this case vessel moves the same distance. And so kind of at an average speed of 11.3 knots, and because they're reducing speed, they're spending more time at sea to cover the same distance. There's resultant reduction in CO2 emissions, but then also by reducing speed, they're able to reduce the CII score. In another scenario, we look at 10% speed reduction again, but instead of covering the same distance, in this case, we're looking at the same time at sea. So 50% of the vessel's time will be at sea. The result of that is that they cover less distance. So in this scenario, there's kind of a commercial or revenue implication, which is probably pretty negative for the shipping company. So the impact, however, on CO2 and CII is still a net positive. So you're reducing your CII rating, but again, in a scenario where you're reducing your speed, but spending, basically you're reducing your distance as well. Have a kind of a revenue or commercial trade-off there that has to be really debated among the company. There's also scenarios, again, where the levers where you're spending 10% additional time at sea, so at the same speed. So here is a kind of a commercial or either market-driven decision where it allows you to kind of, I guess, trade over either greater distances or longer durations or time. So in this case, they would be operating at the same speed of 12.5 knots, but instead of 50% of their time at sea, they're spending 60% of the time. So they're covering more distance. In reality, that of course creates more emissions on an absolute and percent basis. But because they're spending less time in idling, they're able to still reduce their CII by about 3.5%. And then, as we mentioned, one of the other levers was then kind of auxiliary consumption. So looking at the possibilities for basic load reduction. So in a scenario where you reduce basic load by 10%, but then operate at the same speed and spend the same amount of time at sea, you can see here that you're still covering the same distance, but because you're optimizing kind of the basic load, you're able to still reduce consumption because of your auxiliary machinery optimization. So you're able to reduce that CO2 by around 2%, which also still has a positive impact on your CII. So again, pretty simplistic, but in this you can see that the speed is quite a good lever where commercially or market conditions allow it to be able to reduce your CII, and then in combining a speed reduction lever with basic load reduction, which is not uncommon and is certainly possible, you can see how you could positively impact the CII in this particular case. So with this in mind, and as we talked about the levers, coming kind of from the performance perspective of Navtor, how do we help customers typically achieve their CII targets? So it comes with one, understanding current situation, where are we today? And then ultimately, what actions can we take in order to help achieve some of our targets? So for those that don't really know Navtor, we were founded in 2011 with headquarters in Egersund, Norway. We're more than 135 employees today, spread over 11 countries globally, with even more distributors worldwide. And right now our services and solutions are on over 7,500 vessels today, with customers in more than 60 countries. And so we're kind of the genesis of the company is in e-navigation, but we're continuously expanding our portfolio. And really the vision here is to offer a total ship operations platform to the industry, with the ultimate goal to help companies become more sustainable and efficient in their operations. And so we're rapidly evolving and quite aggressively adding new services and solutions to our portfolio to help address more and more of customers' pain points, kind of as a one-stop shop. And so on the right-hand side, you can see our digital ecosystem, as I said, is constantly expanding. And the goal is to provide integrated solutions that really provide a seamless experience, not only from ship to shore, but also among stakeholders across the industry. So being able to create greater transparency between ship owner, charterer, technical manager, and other stakeholders and regulators as well is a very important part of what we do. And we believe that kind of by creating a single source of truth, we're able to help achieve a lot of the objectives of the industry. I'll be kind of talking through some of the interesting tools in our NavFleet product. So NavFleet's again our total ship operations platform, and this is focused more on the fleet monitoring and the performance side. And so we have a voyage planner that helps operators understand how vessel speed impacts voyage CII. Within this, there's an integrated voyage calculation, and we use our own kind of vessel-specific performance models to accurately predict things like voyage costs, emissions, consumption, and CII rating at the fixture stage. So think of this as your pre-fixture or planning tool that's in effect. And so operators can use this to enter in a voyage itinerary. So arrival information, departure, draft, other kind of voyage instructions, such as avoiding eco zones, piracy, or other block areas like the Panama or the Suez. And the system will then calculate distance between the 2 points. Also calculate any distance spent in eco zones, and then also you can input fuel prices here. And so with that information, the system will then run simulations based on the existing propulsion efficiency of the vessels and at different speed profiles. So eco speed, full speed, slow steaming, and then even manual speed instruction will then calculate at these speeds. We'll calculate the total voyage consumption, emissions, fuel costs. And then I think importantly for our discussion today, we'll predict the CII from that voyage. So from berth to berth, what is the predicted CII attain score, the letter rating, and then also looking at the change to your CII over a 12-month period. So of course we can look at this on an individual voyage level, but then also understanding the broader impacts to your vessel are important, and it allows you to make better decisions in terms of nominating vessels for certain voyages based on not only commercial but also regulatory compliance. We also have a dynamic fleet dashboard that allows users to view kind of status for individual vessels, sister vessels, or the fleet at a simple glance. And so with a kind of a simple view, you can get an understanding of the vessel's CII rating from A to E in kind of a simple BI tool or dashboard. And so bar plots here would indicate the vessel's CII rating from A to E. And then this bar plot can be expanded for each vessel in the fleet. And then with that, you can see kind of 90-day moving average to see the more recent development of CII for the vessel. You can look at the period average. So over the past year, what is the attained CII rating? And then also you can see kind of through hover over functions what the deviation is from the required CII. So you know how far you have to go. And then again, going back to the levers that you can pull for achieving that. And then we also have ongoing tools for voyage analysis that allows you to look at current or historic voyages, either on an overall voyage basis or on voyage legs. And so within the voyage analysis tools that we do have available, you're able to see a lot of kind of environmental related information around total CO2 emissions, the CII rating for a particular voyage, as well as the kind of the attained score or rating. And then you can also use this for other kind of operational, commercial, or technical purposes, looking at voyage execution, charter party performance, as well as other kind of key efficiency metrics here. And last but not least, I think the flexibility to pull data from the system. So CII data extracts that you can pull on an annual basis that then cover vessels' capacity, distance, CO2 emissions, attained CII, required CII, and ratings is, again, a way that we provide flexibility for our customers to either perform additional analysis on their own or share this data with external stakeholders as well. So that's kind of a fire hose of information, but I think some of the key takeaways here, what we didn't talk about earlier, but through the methodology, based on IMO's methodology, about 35% of vessels using 2019 data won't meet IMO's CII target of a C rating by 2023. And so again, there's a number of ways and levers that can be pulled for companies to improve CII, including operational and commercial levers such as speed, basic load optimization, hull cleaning, and others. And so I think that the combination of our voyage planning, fleet performance, BI tools, and voyage analysis modules are certainly things that can help customers not only better understand where they are today, but then also run scenarios of the future and understand how certain operational, commercial, and technical decisions can ultimately impact their CII rating and their ability to meet long-term targets set out by IMO. So that that concludes my presentation. And as always, feel free to reach out if you have any other questions. I'll go to the Q&A and also check those as well. But we'd love to have discussions with you on the webinar today if you have a need for further information.
Thanks a lot, Aaron, for that interesting presentation. Yes, please check the Q&A and then hang on to the final discussion session here at the end. We'll now focus on Thor Øyvind Ask from Solvang ASA. Hello, Thor. Can you please say a little about yourself and then do your presentation?
Thank you. Yeah, my name is Thor Øyvind Ask. I'm a fleet director in Solvang. Have been there the last 15, 16 years. I have really a responsibility for everything which is going on board. Before that, I have some years in offshore supply in the same position. And with my background from 4 years ago is as a second engineer, and after that a master and a PhD in engineering and shipping. So I have started on the ship many years ago. I was challenged to talk about weather, the effect of weather routing in or the weather related to this CII, and it's not so often I do that, but I've tried to put together a presentation, and I hope it at least explain something of how we experience this new requirement and how we have been working up to now. Let me see. Yes. First, a couple of words about Solvang. We have 27 vessels. We have 3 different classes of vessel, or really 4, but it's very large gas carriers, ethylene and ethylene carriers, 9. So totally. We funny fact, 5.8 million tons of cargo. We travel 105 times around the world every year, and we use about 250,000 tons of fuel, 1.6 million liters of lube oil, and emit 785,000 tons of CO2 by running the main engine, 158,000 hours, auxiliary engines 352, and the boilers 32,000. So there is where the emission come from. Our history is back from 1936. It was from 1936 to 1989, because a company which handled this is a stock market, but it was an investment company. From 1989 to 2004, it was converted to the shipping company today, and in 2011 we started a program we called ECO, the ship for the future, how we should build our new building. In 2000, as you can see on this figure, we have already put up the history up to 2025, 30, and 50. So we have our plan to be in this business for many years still. As it had been touched about for many already, this with the CO2 emission is only one part of the thing. We are bombarded with regulation, and we need to handle all the environmental aspects at the same time. So some it's mostly covered by regulation, but it is a big push on us to improve on all the environmental aspect we have. So of course it's to the air, which is CO2, SOx, NOx, particles, unburned fuel, CO, greenhouse, and also other greenhouse gases like methane. So it's what going out of the funnel. We have to the water, we have garbage, we have noise, and all this need to be handled at the same time. What's one of the environmental footprint in operation is what we're really talking about. We build vessels, but then we are operating them. And what we think is not so much focused on, but what about the thing we do when we operate our vessel. It's correct. The environmental footprint depends strongly on the operation and maintenance of the equipment on board. Wrong operation and poor maintenance can increase emission far above the values which we believe it should be. So continuous improvement, that is operational procedures and all this, maintenance, technical solution, retrofits, but optimal speed and route was the thing we identified many years ago, and it's of course one of the things which can destroy everything if we end up with a lot of bad weather sailing. So as you say, the previous speaker, also cooperation between ship's master, customer, and organization around is crucial to really achieve something. The IMO target is clear, and we know where to go. And the challenge with this RAR, as it is at the moment, there is many ways to measure carbon intensity, and the one which is chosen today is this RAR, which is the deadweight way to look at this. 40% from 2008 to 2030. 70% by 2050, but we first need to come to 2030. And the challenge is that they don't know what the emission was in 2008, and that is of course one of the tricky thing here. How can we measure a 40% reduction when you don't know what the case was in 2008? And we have, based on our own measurement, we know what we emit in 2009 and 8. But it is they're still discussing this. Therefore, also we use this 2019 CO2 measurement to make the baseline. The most important thing from a ship's owner perspective is to know how the vessel operates. What is the speed? What is the consumption on the different equipment on board, and all this? And this varies a lot from day to day. So this is not. Our system is based on a day-to-day measurement, which is aggregated to months and year. We started with an in-house system in 2008. We now use another system, which is a Storm Geo system. But it is really the same thing. We measure the distance through water, distance through over ground, the fuel consumption on all the different equipment running over and this, to get the view how the vessel is operated. On this, we also have a calculation of something we call performance speed. You have a speed over ground, which is quite simple, and we also calculate the Storm Geo also calculate the performance speed, which actually try to compensate for the weather. So because we try to see where is the vessel related to the baseline it should be. So every month we go through this and make reports so the vessel can actually see how they perform. Because it doesn't help what we do in the office if we don't get the people on board together with this to understand and try to improve and see when things is going the wrong way. So we make monthly reports, which is aggregate, compare the vessel with the sister vessel and how is the consumption per 24 hours on the main engine, on the auxiliary engines, how is the cooling been done, how is the boiler been running, and all this to get a view, because the fuel consumption doesn't come by itself, it is made by some equipment which is running, and that is what we need to control. So this is also basis for the SEMP they will make and also the follow-up meeting. So this is followed up quite closely every month and of course, during the end of the year with a management review and master's review and all this to put up targets. when we look at this annual efficiency ratio, we have already been discussing this a lot already today. But it's one of the tricky things for a ship's owner perspective is this, that you count also at harbor and idling. And I'm quite sure this have to be corrected with IMO next time, because on the regulation they stated on a voyage, and a voyage is not if a vessel is don't have a cargo, don't have any job, it's not on a voyage, and this RR factor is made for a vessel on a voyage. So it doesn't work, and it can really destroy the performance for a vessel totally if you get a lot of idling, because the consumption on board, as have been discussed already, is still consuming fuel, but it doesn't sail anyway. So it should be there must be some correction here to get this to work. We have one vessel particularly go from 16 gram per ton mile 1 year to 28 the next year, from a C to a E vessel, and there's nothing wrong with the vessel. It's just that is the way this is calculated now. So I'm quite sure this have to be corrected for. But what can we do on board, and what can the people on board do? Because we also make this a little bit to a competition and try to, how can we, they can of course affect the total CO2 emission by using the auxiliary generator, all the fuel they use on board, to look at how we do that. And that we have been doing for years. And the other thing is distance sailed. And it's already been discussed, but it's to get a longer distance, the IR will go down, and that is positive. So maximum time at sea, maximum time sailing ballast, because then we have lower fuel consumption. So for example, if you go from US to Far East via Panama and ballast via Cape Town, you will of course get a better CII because you have a longer distance in ballast. Speed is of course extremely important, and in the end you have this use weather routing to avoid bad weather. And of course, if you can sail in a way you get the current with you, opposite to the against you, you can gain a lot by using weather routing and using the big map where to sail. The tricky thing with this CII is this is a moving target. A vessel which is good enough in 2022 is not good enough, maybe not good enough in 2026, or from 2030, we don't really know. So it's a quite tricky thing, this linear. If you look at the average for a fleet, for a ship's owner, you can say you take away old vessel, in with new, you get a stepwise reduction. But for a single vessel, decrease the CII every year, that is difficult, because after a dry docking, this will go the other way. So then you can reset it in when you do hull anti-fouling and do hull maintenance. But it is really from every day you are in the sea, the hull degrade. So we're actually fighting against the nature here. I was challenged to a little bit with this with weather routing, and we use weather routing in Solvang, and I think there is quite a it can solve that we don't run into, sometimes it can solve that we don't run into problems with CII, but it's also limited what we can achieve. And there's also a conflict. The way we use weather routing in Solvang is starting point. When you're making a voyage, you use from Europe to Houston or wherever, you make up a route which is the shortest route. And then you take historical weather and in area, wind, current, temperature, and try to see where is normally the bad weather is. The current, is there something this time you can use. The Voyage is transferred to a weather routing platform and simulated against the weather forecast. And when you have chosen a route, you will get weather update during Voyage. And in the end, you can see how this is going, if it was a lucky choice or not. But we see clear that this CII will benefit from longer voyage in better weather, may be in conflict with the fastest route. So you get, if you can, you should always sail around the storms and go in bad weather, good weather. But of course, that is not possible because you need to also get the fastest route. So this is a conflict, and we are discussing how to get the operation and all the part involved to understand that this is something we need to have in mind. This is just a snapshot, and you can see in the middle here, you can see a couple of vessels. One is going to Europe, which is Daoust, is in the middle of a storm, and the other one is going the other way, and the storm. So this is not easy to avoid, and therefore, if you operation in North Sea and also Atlantic in winter, it's difficult. You can avoid to go straight into it, but we have many cases where the vessel is fighting in 10 knots, and that is really where you end up, because you cannot. The storm is so big, you cannot go around it. It's just an example of how we normally do this, and this is one vessel in Houston going to Europe. They have planned a voyage, and you see it seems like they're going in straight into a storm, but that storm is moving. So you see the first is December 22nd, and the ship is, maybe you can see my pointer, is sailing, and the storm is also moving. So it's ending up that they will not go into that storm because that have passed, and it will be updated during the voyage. So if they try to if they they try update the weather forecast and try to get the best possible weather through the voyage. But as I said, it's especially the Atlantic, but also the Pacific. Its shortest route is up, and the winter weather in the north is quite rough. So this is a tricky thing to also prove in the end. Also, we're talking about RAR, which is the deadweight based efficiency factor, but we also can make an EEOI, which is the actually cargo based efficiency factor. Solvang have been working very hard with this for many years, and you can see our different fleets, which is the gray in the left is the ethylene fleet, the red is the large gas carrier, and the black is the red is the very large gas carrier, and the black is the large gas carrier. So the improvement from 2009, looking at RAR for the fleet wise, is about 33% this year. You can also see the blue, but this is tricky because if you look at the fleet, if you sell an old big vessel, and because the fleet size, the size of the vessel, will affect the RAR. So if you see the blue one, which is the average, going a little bit up in the end here in 2021 compared to 2020, and that is mostly due to this one of the big vessel which was sold. You can also see the ethylene fleet, which is this going up from 14.6 to 16, and that is mainly due to one vessel which was idling most of the year, which destroyed it. So this is fleet. It's a sensitive, and it need to be corrected for when the vessel don't have a job. It should be at sea, and the factor to the right, energy efficiency, EEOI, is just counting when the vessel is sailing, actually on a voyage, and you see there it's almost flat. One other thing I want to show this, that everybody talk about the vessel need to, the ship owner need to improve and it's need to start. And I'm a little bit, this is not something that started now. This has been going on for many, many years. The improvement is clear, but I think the ship's owner and shipping companies are very not particularly good to say and tell what they are doing, because the environmental footprint is a huge improvement now, just compared to 15 years ago. So this have really gone on for many years. And another way to look at this, if you look at our average fleet size in 2009, 2014, and 2021, you can see the deadweight have increased from 40,000.4 to 49. At the same time, the actually cargo capacity, excuse me, that was the cargo capacity, the number of cubic we can carry. The deadweight have increased from 32 to 37 or 36.6. At the same time, the fuel consumption have gone down from about 130 liter per nautical mile to about 110. So the vessel becomes bigger and bigger, while the liter consumption per nautical mile are reduced, and that is due to anti-foulings, weather routing. It's about the better hull design and all the things, better engines and better operational procedures, and everything we do then. So, summing up, reducing fuel consumption and carbon intensity have always been an important part of the shipping, because it also reduces cost. And I think that's also an important message when you look at the stakeholder around and tell them that really what have been going on. I think weather routing is important to avoid unpredicted increase in CII. If you are sailing in bad weather, and in good weather, you cannot be better. It's in a way try to reduce the risk and increase in CII. And also this is the conflict between commercial shortest time and longer distance and good weather, because the longer distance and good weather will always give a better CII score than sailing in bad weather. So here we have, and we see already, we are discussing how to handle this. And back to weather routing again. It's depend on the area which you are sailing. It's the improvement, the possible improvement is strongly dependent on which area. If you are going in the Mediterranean, normally you have quite okay weather. You're going in the Caribbean, you normally then there's a current you need to be aware of, and it is this big picture which is important. In some place it is extremely important to avoid it, because you also actually you're sailing in 10 knots instead of 16, because of you have all the things against you. And I think the CII need to correction factor to work. Whether for some to operational area, idling, port operation, special operation, as we often do, it's you are laying as a floating storage and tanker, which are getting cargo on board, and you deliver it again, and you use a lot of fuel, but you don't sailing any distance. So there need to be some sort of correction for this type of thing. We have cooling, heating of cargo. We have cooling, of course, since we are transporting liquid cargo, which is liquid gases, which is between 104 and 50 degrees. Do we get hot cargo, or do we get this type of thing? That is not our fault. So it must be some correction here, which adapt this to the real life, if this is going to, as long as it's just a number. But when you go into this about this C rating, going into D&E, you need to do something, and then it's have to be something you can do something with. So that was my presentation, and yeah, thank you for listening.
Thank you very much.
So I guess you need to unmute. But I could almost read your lips saying, Klaus, would you like to introduce yourself? Well, I can't hear you, Soren, anyway. I don't know what's going on. But my name is Klaus Andraesen. I'm from Vessel Performance Solutions, where I'm Business Development Manager. I've been around here for almost a year. I have a long career within the shipping industry. I've been around as superintendent for more than 15 years. I've been building ships for major shipping companies in Copenhagen area, and then I've been around with different service providers into the shipping industry. So I like to present how we in Vessel Performance Solutions do use our services to optimize your fleet's CII rating. So we share screen here. Oh. And here we go. Yes, so Vessel Performance Solutions is a Danish-based company. We're based in Copenhagen. We have a subsidiary office located in Athens. We are from 2014. And what we do is actually that we bring consistent insights of the vessels in operational efficiency to the different stakeholders around the shipping, so they can make informed decisions about, for example, reducing CO2 footprint or optimizing CII, and so on and so forth. So we are you can say, a knowledge provider into this. So what we do is that based on noon reports or sensor data sent from the vessels, supported by hindcast weather and AIS data, to increase the quality of the analysis, we take the data into our service. We analyze the data quality, see or we validate the data quality, see, amazing reports, is data out of range. So we are working on the right thing. And then we process that information, for example, into commercial information like charter party compliance, weather routing compliance, voyage progress and instruction. We also look into more technical details like fuel consumption in various relations to speed, RPM or power. We look also into main engine specific fuel oil consumption and comparing peers, comparing ships into that. We also look at the technical thing as Holton propeller performance, added resistance since last dry docking and things like that. But today we're going to focus on the environmental side of it, the CII ratings and the present trends and the impact of trade parameters on future CII ratings. So how did we go about this? Yeah, we actually asked our customers, what would you need from us to be able to take a proper decision, informed decision about CII. So, and it is like this, a system like what we supply is that there's plenty of details all around. So the first thing was we want an overview of the present CII status of the fleet and see if put everything else equal kind of angle on it and see if there's anything else, if everything else is equal, is anyone ending up in D and E with the present trade pattern and when? And then also because everything is not equal. So what happens if, but before you can say what happens if, you need to understand the details of the parameters that impacts the CII rating on each ship. So we also provide the details of those parameters in different views and different time periods and so on. And then they would like to simulate if any vessels end up in D and E with a foreseeable time trade pattern over time, and especially as CII goes per calendar year, it's interesting what happens late December. So, but they would also like to simulate how different charters, trade patterns, seasonal trades would impact the vessel's CII rating. And then from there, be able to optimize what would make the most revenue, avoiding vessels ending in D and E. So this is the basic overview, everything else equal, same parameters as last year. So if we look at this overview here, we're now just out of 2021, and all vessels in this scheme here is in B, and they came out as 47% into B, or 34% into B, and only 3% into B. And then what happens in the future? Yeah, the ones with the higher into B, eventually they will go into C if they're trading on the same parameters as they did in 2021. Now we can put it in a more specific way as well. You see here, it's the same parameters, 3.79. 3.79 will eventually end up in C. And you can look at it here as well. So if we look at the details instead, you can see we have the details here. We have the development in AER over years, which is and we operate with 12 months rolling here, because as it is a calendar year kind of calculation, if you were calculating year to date, you will have a huge variation every January in the first part of the year, and with that, in our opinion, that would just confuse the picture. You know, trades are not changing that much just over time. Is our first approach. Of course, we do have the CII year-to-date ratings as well, but this is our preferred way of looking at it. We also have the speed over time, the speed over shorter time, 12 months and 3 months. But here we have a view of what are the parameters that you can work with when we're talking CII. And in case of this vessel BU, if it keeps on like this, it will end up in D with a CII rating of 6.46, and C in the year is 6.87. So now we know what the details of the vessels are. So now we can look at try to play and simulate what can be going on with this vessel for you can say a more long-term simulation. So we have the parameters here that owners can impact, which is speed, fuel type, and decay. Speed and fuel type do have some significant impact on CII, and especially if you choose LNG or biofuel. Decay have some impact. And then there are the more voyage-related parameters, which are hard to impact from an owner's point of view, as was said earlier on. But they do impact, and ballast laden ratio and utilization has a significant impact on the CII. So let's have a look and try to look at what we can do actually. So here is the same ship, and what is interesting is actually because the 2024 date is where it actually starts counting. So if I want to be in C in 2024, I need to meet this corner. So we can say, okay, what is this corner, the upper corner. So what would we need to do to be in C? Then we need to say, okay, let's see how big what the fuel impacts here or the speed impacts here. See, oh, something going on here. So it's a little slow here for one reason or another. But if we lower the speed to 15 knots, you see we definitely were there. So speed has a large impact. But maybe we can manage by doing 16 knots then. You can see 16 knots. Then we will definitely just be here. It's very close. You can see here it says 6.53 is the C rating end 2023, and actual what we are ending up is in 6.56. So there are other things that we could look at here. If you look at the utilization rate, for example, it is 63. We are only calculating, you can say, or simulating with tenths in difference. So if we do a jump to this one, I'm sure it makes a major difference. You see, it made a major difference. So and in this case, let's just put it back to 16 to 60. And then you can see here we have a dry docking coming in, and that's the reason why the figures are going down here. We simply calculate that the added resistance here is being much less than it is now. So you can see that we have some room to optimize after the dry docking. We can go to the upper corner here. And maybe we can sneak for the rest of 2024. Maybe we can do another half a knot increase. And then you can actually also see that with this 16.5 knot, we have more room to go for in 2026. So maybe there's another half a knot to go for. So all this is just to provide information and knowledge that, okay, this is what it looks like in the range of what we can do. So as an overall kind of looking into what impact has the different parameters, what impact has the fuel, and we can, for example, if we go to LNG, as was said, that would have a major impact on this, but it's hard on a container ship which is equipped for an ordinary fuel oil consumption, certainly to shift the whole thing to LNG, but it has a major impact, and then you can basically sail much faster. So this is one view of it. We can also say that if you look at it on a more annual basis, the impact of the trades, as has been said before, also have an impact on the CII. So some vessels are trading, or in some sectors of the shipping, vessels are trading in a seasonal pattern for one reason or another. So some part of the year they're selling faster than other parts of the year, and this is what we're trying to simulate here. Now this vessel BU is presently in heading for rating E, but they don't like that. They would like to go to C at the end of the year. So they're now proceeding at 17 knots. So if we say that they do that until the 1st of May, and then they from the 1st of May to 1st of August are offered a charter where they have to sail faster. The charter also guarantees that the utilization will be 70%, and we think that the Beaufort, the weather impact here will be Beaufort 4. Then what price is it on the other side of this voyage? What impact does that have for the rest of the year if the owner wants to go to a sea? So they're sailing fast in the spring and until summer, and then after 1st of August they go down all the way to 15 knots and all the way down to 12.5 knots after 1st of October. That is the price for making a sea and for sailing fast in the first half of the year, plus minus. Then the stakeholders, they can say, okay, am I willing to do that? Is it commercially viable to do that? Yes or no? Maybe it is, maybe it's not. But with these parameters, you can simulate what is, on a general basis, the impact of a certain voyage, what is the impact of a trade pattern, what is the impact of a seasonal change in trade, and you can see and optimize on, okay, but what is the most optimal way to earn money? We don't have the money part in here. We only provide the information that this is how it looks, and then other BIs comes in with information about charter prices and all that stuff. But in this way we provide the information to the owner so they can decide and look after their vessels. So the asset is not kind of deteriorating in the last part of the year because they only have to sail 12.5 knots. With us, they do that with an open mind. It's a well-informed decision that they do that. So this is the way we think. Provide information, others decide. So and these are the most you can say important parameters that we play with here, but there are of course others as well. And I should say this is a recent development, and as biofuel is coming in as a player, not as a player, but as a solution as well, it will have a major impact. And one could also think of, and that is what we are going to introduce at a later stage, that you can say, okay, in the first part of the year we sail on the cheap fuel and we sail fast. We know we are burning CII, but then we are willing to invest in biofuel the last part of the year, which will have a less impact on CII, and then we can keep the speed. That's another way of looking at it. We're not completely there yet, but we will be there. So I think that was basically it. So I kept it quite short. We've only scratched in the surface what is possible and what we can do with the Vespa services and here. But I thought you get the point. There's a lot of information to be gained here with the simulation, and we have a lot of more and in detail information that we can provide to you already, and more is being developed in dialogue with our customers. Thank you very much.
Thank you very much, Klaus, for this interesting presentation. So now we heard from some service providers on how they can handle the CII for the future. We heard it from a vessel owner how they do it in practice, and we have seen for the CII, since it's been chosen for something that you are rated on, and you can see, okay, it has some flaws. It can be good for some cases. So I guess when we reach 2026 and everything has to be reviewed, I think, do any of you have any foresight on, will the CII still be the AER? Will it be the EOI? Will it be more strict? Does anyone have any comment on that? I think maybe we should start with you, Thor, because I guess you mentioned first of all the exemptions that we think will come on the CII, but also what you have been doing all the time. So what do you think about the EUI and the CII, and what do you think about 2026?
I think it have to be revised. We need to get this in this exemption processes, and I think it will be OIR still, but I think we will move against the direction with EEOI, because that is make more sense, and everybody can prove a better, that we have even more, because we have built that vessel with bigger cargo capacity related to the dead weight, so the dead weight don't tell the story. And I'm also quite sure that we will get well to wake on fuels, and we will get all greenhouse gas involved in this, because it has to. If not, it doesn't make sense. We know that LNG, we have biofuel, which is not sustainable. I think maybe not in 2026, but when we see 2030, we need to recalculate all this, and all this other parts need to be in it, because if not, it doesn't make sense. We're just moving the CO2 emission around. We don't eliminate it. It's disappear from the vessel, but it pop up another place in there, and that is not what we want. So I think this revision, as I said, there have to be a revision. It's just a simple thing as our gas tankers. They are compared with, we are transporting on a smaller vessel, we are transporting ethylene, and they are compared to LPG tanker, which have a cooling maybe on 50 degrees, but we have ethylene which is 104, and of course the cooling demand on that cargo is much bigger. So you cannot just say an LPG, the cargo you handle will be different. It's the same if you also need heating. So but how they will do that with this operational area, because we know operation in North Sea compared to Atlantic and Mediterranean, Caribbean. If it need to be some sort of thing which make this in a way so we can handle it. If not, it will be stupid. And it's the same, a vessel which is laying still, it's emit very little CO2, but it have a very bad intensity factor. So this is something which is going against each other, and it have to be rectified, I'm sure.
Okay, thank you. I agree with you. That is something that, but I also think that a review period for 2026, I think maybe it's also reasonable to have some years to review it, right? So what about you, Aaron? Do you have any in your crystal ball at Navtor?
Yeah, I mean, I think I would echo a lot of what Thor was saying. We were expecting a lot of the same things. Obviously, by then they'll have to address the reduction factors post 2027, and kind of up to 2023, we were looking at a 5% reduction from the 2019 reference line, and then moving to 11% by 2026. But from everything, kind of our discussions and what we're reading, in order to meet a lot of the long-term targets, there would have to be further reduction post 2027 to 2030s in the range of 11 to, I think, upwards of 22% reduction factor to meet some of the long-term targets. And then, of course, as Thor was saying, also the kind of the more guidance on the corrective actions, what's going to happen in the case where you're not meeting those targets, and how how punitive can you be, I guess, because right now when you have the D to E rating for 3 consecutive years, it gives a pretty long window to put together a corrective plan of action, implement that in your SIMP, and then move forward. And so I think there's probably a lot of people that can argue whether this regulation is enough given the kind of way it's assessed now, and is it really just a slap on the wrist, or is there something more that can be done to encourage better and more efficient behavior from the vessels? And then, of course, with the correction factors and taking into account all of these voyage exceptions around ice conditions or adverse weather, long waiting times in port, cargo heating or cooling operations, those things will certainly have to be factored in to, I think, make this more of a balanced analysis.
Okay, thank you. What about you, Jeremy? You have any?
Yeah. I mean, I think it's interesting, and so echo my colleagues. Of course, I think logically we can all agree that, and if in shipping, if there's one thing that we all are, is students of history. Shipping is steeped in history, and so if we were to look at how IMO regulations have been amended and evolved through time, I think we could. I think it's a fair and safe bet that there will be some changes to how this is the tools that we have in a way that we, as an industry, I mean, the whole point is to go to decarbonization. That's the point. Now, the methodology and the tools and the way that we get there are being drafted, and so I think it's not an easy journey. And so let's start with what we have. And certainly, I think we all agree that when we do the calculations, I think there are a lot of really wonderful comments that said, well, look, there's some interesting hacks to get a positive CI, but commercially it's completely non-viable. And that's always the bit, and it kind of ties with the conversation or with the piece that I shared. It is guys, I mean, this is multidimensional. The commercial reality, every voyage is about a commercial contract, yeah? And so that charter party, which we didn't discuss today, there are clauses in the charter party, there are stakeholders, there are concepts such as demurrage, which today really hurt potentially CII, right? And so as an industry, we need to look and we need to look at all of these different verticals and find a solution that really, really, really works. So I think there'll be some changes. And I think the other aspect too that's also interesting is there are pain points in operating model for sure, but these operating models and trade routes tend to be together. And so you will be, for the time being, competing with people who are suffering with the same kind of issues with long anchorage stays or issues, with transatlantic crossings in winter. And so you potentially could be compared with peers suffering from the same problems or the same complexities in operations. So at least there's a bit of an apple-to-apple comparison there, depending on the trade routes that you're operating in. And so if there's a bit of solace, there's in that for the time being. So do your best with that your fiercest competitor is in the same boat, as it were, because he's trading in the same operating lane. So we'll see, but it is complicated. And I don't envy the seafarer today who has to deal with all of this on top of everything that he has to deal with today. It's going to be interesting.
Sure will. And you, Klaus, you have any thoughts you want to come with on this?
No, I'm not really. There's not much to contribute with. I think there's a very viable inputs here, and shipping is dynamic. And sometimes one day you parked outside Shanghai, as I read in the media now for maybe months, and it's just the trade. Nothing about that. It could be the most environmental fit shipping company and vessel and crew. And then they suddenly park there, and then they should be punished. It doesn't really make sense. So I think that of course there has to be something that adjusts the trade, take the kind of trade pattern out of it, and then focus on the what the owner, what the charter, what is impacted by human beings basically. So I think that's the point.
Sure. Okay, I get it. Tomorrow we'll hear from BIMCO, right? So there's something on the commercial side of it. There's something about a charter contract, and then we know that they are working on getting the EXI in, and also perhaps the CII. I don't know, but we talked about this transparency because now the charter market, to some extent, is like hide and seek, right? There's an owner who has a fuel oil consumption. There's a charter who has a contract, and there might be disputes or claims or something like that. Do you see this changing the market? So because the owner, he wants to take care of his CII, and the charter, of course, he wants to have, let's say, energy efficient vessels to operate. But do you see a larger transparency coming in with this CII? Do you see owners sharing more information with the charter, or do you see it as a necessity? Do you have any input on that? Thor, you're the owner side. We are the service provider side. Do we see our product being a sharing tool between the commercial and the owner side? I think you're muted still, Thor.
Yeah, definitely we see that. And the problem with all this is that there's a lot of system which charters want to put on board in a vessel, but the data is not qualified. It's not evaluated. And you end up with a different CII because there's some mismatch there. And what we see is that all the data need to be looked at and see, are they correct, are they not correct, what is the situation there. But definitely there is a big push to sharing more data, and that is not the problem. The problem is how you share them, and that you can be sure that we in the end of the year sitting with the same data as the charter do. So I think it's to have control of the feed and not just putting on board things which some charter want. That is not a good solution, because I think everybody gain of being transparent, but it is, you must, if you don't understand the numbers, you're just making a lot of confusion and creating more hassle and more work, and we see example of that. So how to deal with this in a good way, I'm not sure, but I'm very skeptical to need to be, the data need to be controlled, verified, and see this is correct, and then it's not a problem to share. But sharing raw data day to day doesn't give any good feeling, because you can be sure there's something wrong from time to time.
Yes, of course. Yes, so, and you service provider, can you see your software product as a sharing tool? Is there something you can see in this, Klaus? Do you have a...
Yeah, definitely. I think this is actually, I mean, having been in a shipping company for many years, where these almost trenches has been between the technical department and the operations department and the chartering department. You know, I think this is a perfect way of getting people to work together in the shipping company. But I also see that the shipping industry is put together in many different ways. So some shipping companies have everything in-house, and some shipping companies just owns the vessel and has a small setup of people, and then commercial operations, technical operations are outsourced, commercial operations are outsourced, and then there's a different. They have a different approach, and it's very interesting when we talk to customers. How do you actually to get to know the different views and the different challenges they work with because of the organizational setup. So I definitely think that this is a sharing tool big time, and I think that the more transparent you can be, the better, because at the end of the day it's about you being good to operate your ship and the crew being good to operate the ship. That's what we should focus at, and then and I think this is fantastic tools to whatever we have seen today is fantastic tools to work exactly again in that direction.
And you, Jeremy?
Yeah, I mean, I absolutely agree. I think technology needs to be an enabler of collaboration and bringing different contexts and, you know, perspectives to the Voyage equation. So fully agree. And I've seen a lot of my colleagues and a lot of our products are heading in a way where we want to enable that collaboration. Now, the tricky bit, of course, is the native silos that we've created in our industry. If you're a deck officer, you're trained as a deck officer, boom, and then you go shoreside and maybe you become a marine superintendent. Same thing for a technical superintendent who is an engineer. Our trainings are very much in silo. We have operators, charterers, and so technology is an enabler, but processes and knowledge and hiding of knowledge, right? Knowledge is power is today in silos. So what we need to do as a community is leverage this technology, create new processes and new collaboration like we've never had in the past to have this successful venture, which is the Voyage. So we want the Voyage to be we all do. We want the Voyage to be as successful as possible, but that's now hitting a lot of different angles. And environmental compliance and reduction of carbon emissions is a huge one, which we're all stakeholders in. And so I think our platforms, solutions, digital solutions will help bridge these gaps. But man, we need to start training. We need to start cross-pollination of deck officers and engine officers and shoreside and really get all together and have a good conversation and start working together.
Aaron?
Yeah, I don't think there's much to add here. I think everybody said it exactly right. There's the inherent tension that's always existed between owner and charterer. And so finding ways to kind of create more of an openness and transparency without the fear of repercussion in the form of claims or others is really important. And so we've seen a greater desire for that transparency. We have a charterer customer that's provided owners open access to the platform so they can see all of the data and information that the charterer can see can be seen from the owner side. And we're even seeing that with respect to technical managers as well. So again, everybody has access to the same information. As Tor said, the data sharing may not necessarily be an issue, but the way that you look at it and analyze it may be different in every scenario. So it provides a common level of understanding and openness to try to work together towards solutions, which is important because Soren, as you said, the charterer may get the fuel benefit of more efficient actions, but then the owners dealing with the emissions reporting, their ESG reporting is tied to that. And so how do you create circumstances that are mutually beneficial, not only for the stakeholders involved, but of course, the whole reason for all of this is to reduce the environmental and footprint from the industry. And so I think having that transparency is an important early step in order to help achieve these bigger ambitions.
Yes, I think you're right. All right, guys, but I think it's time to wrap it up. Thank you very much for your presentations. Thank you for your attendance. It was very interesting to hear your views on CII and voyages. This session is being recorded and it will be available afterwards for any other audiences that didn't have a chance to monitor this. So thank you very much. Tomorrow there will be another series of presentations. We'll have from BIMCO, we'll have from Orbit MI, Marine Digital, 2020 podcast will come, and Navidium will say something, and Spire Weather will contribute with some views on this also. So I'm looking forward to welcoming you again tomorrow with a new set of speakers. And thank you to you speakers, and you enjoy the rest of your day.
Thank you very much.
Thank you, Soren. Thanks, everyone.
Thanks.